Good morning, friends. I am here again for my course Aircraft Systems. As you know that I am in the process of describing the different types of aircraft systems. I have completed all the 5 volumes of this course. Now I am going in detail of different types of systems. Today I am going to discuss about a case study on 270 volt DC power supply and why it is required. You know that the United States of America, they are producing a very sophisticated fighter aircraft, F-22 Raptor and F-35 Lightning aircraft. They are very much stealthy aircraft. B-2 bomber and all. There they used 270 volt DC power supply. They don't use 28 volt DC or 150 volt AC supply, because these supplies, especially the 115 volt and 400 hertz, they are this is the alternating current, and this alternating current will emit so much electromagnetic waves. This can be detected by the enemy radar. To avoid that type of scenario, US industries, aero industries, Lockheed Martin and some other, Boeing and all, they have started using another type of power supply that is called the 270 volt DC power supply. So I am going to discuss about this. Before that, as you know, my name is Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. And these are the topics. And this power supply is the part of the module 2. And here, all these topics I am going to cover, and they are the part of the course of outcomes CO2. So the first topic I am going to discuss about emergency power generation. It comes under CO2. Then RAM air turbine, it is also called the RAT, it is also CO2. Permanent magnet generator, it is called PMGs, CO2. Recent systems developments, CO2. Variable speed, constant frequency, CO2. 270 volt DC system, CO2. These are my topics of the day. So I will talk about emergency power generation. Emergency, when it is not a normal power generation, that time we should use the emergency power generation system. In certain emergency conditions, the typical aircraft power generation system may not meet all the airworthiness authority requirement, and additional sources of power generation may need to be used to power the aircraft system. The aircraft battery offer a short-term power storage capability, typically up to 30 minutes. So this is the time where your emergency battery is also placed in your aircraft. This can operate a emergency systems only for 30 minutes. Aircraft has to land before it is reaching to the drain out of the battery. The 3 standard methods of providing backup power on civil transport aircrafts are. So what are the emergency power which we need? So first one is the RAM air turbine. It is called RAT. Then backup converters. Then permanent magnet generator. So these are the 3 standard methods of providing backup for any civil transport aircraft. I am talking about the civil passenger aircraft, not the military aircraft here. So RAM air turbine, it is called RAT. The RAM air turbine is deployed when most of the conventional power generation system has failed or is unavailable for some reason. The right is an air-driven turbine, normally stored in the aircraft vertical or nose section that is extended either automatically or manually when the emergency commences. The passage of air over the turbine is used to power a small emergency generator of a limited capacity. Red generator sizing may vary from 5 to 15 kilovolt ampere. The red also powers a small hydraulic power generator for similar hydraulic systems emergency power provision. So these are the points which I have to explain now on how these things are working. So just I will see that if your aircraft is flying like this, all of a sudden your power is failed. Then what will happen? At the nose section here, inside this fuselage, we have a ram air turbine mechanism. This will be operated by the pilot. Pilot will lower it. So initially it is inside, and slowly this thing will come like this. And here is your rotor. Fans are here, turbines. It will be rotating by the fan. It is rotating, and there is a turbine, and this turbine will rotate, and this turbine is connected with the electromagnetic, like a generator, power generation. And generator is one magnet is there, one coil is there, and up to 5 to 15 kilovolt ampere or watt, 15 kilowatt, it can produce the power. So this is lowered by the pilot, and by this some emergency hydraulic systems are also operated. Not only it is operating and giving the power supply, but for emergency powers like your landing gears, your controls, these things will be working with the help of the right or ram air turbine. So here this you can see here how this is the fuselage, aircraft body here, belly. Inside it is stored somewhere here. As and when the pilot is experiencing there is a problem in the aircraft power, or it is automatically also. If nowadays everything is automatic, as and when the pilot is failed, it will come down like this here, and these are the fans. So due to the motion of the aircraft, this will rotate. This will rotate, and here is turbine, and this turbine is connected with the electrical generator. Power will be generated here, and it will give to the emergency alternating current electrical power supply. It will supply, and also emergency hydraulic power. The pump is fitted itself here, and this pump will go to the hydraulic power, and the hydraulic pump will be rotating, and the only emergency systems will be operated by the right or the ram air turbine. So this is a power come hydraulic power equipment which can be used on aircraft in case the power system is failed. So that is the purpose of this ram air turbine. Next is simplified backup VSCF, variable speed constant frequency converter system. So these are the backup system for the power backup. So here this you can see the left engine, here is the right engine. Here you have the left IDG. Here we have the left backup generator here, permanent magnetic generator. Here is a left variable frequency generator up to 20 kilowatt, permanent magnetic generator. Same way here we have the right IDGs. It is a direct generators. Here we have the right VF generator, variable frequency generator up to 20 kilowatt. This is the on off switch here. Permanent magnetic generators are here. Permanent magnetic generators are rotated. This will go to the backup VSCF converter. From here a constant frequency backup power is available. So in case this is holding the power, and accordingly it is supplying for the different systems. Now I will talk about the next power generation system. It is called the permanent magnetic generators. I have discussed this thing. Just you can see here, these are the PMG. It is called the permanent magnetic generators. So what is this permanent magnetic generators? I am going to discuss in this class, in this lecture. So permanent magnetic generators, the use of permanent magnetic generators to provide emergency power. So this is only used for the emergency power. The backup generators host PMG, which supply several hundred watts of independent generated power to the flight control DC system to 28 volt DC. So in case of the main system is failed, this backup generators operated the PMG, which supply several hundreds watts or kilowatts of independent grade generated power to the flight control DC system. It was already explained earlier in the chapter that AC generators include a PMG to bootstrap the excited system. So just now I have given that here backup systems PMGs are available. Permanent magnetic alternators, it is called PMA, are used to provide dual independent on engine supplies to each lane of the flight deck. So these PMAs are fitted inside the flight deck system. In case of emergency, this flight deck will have this PMAs or permanent magnetic alternator. These will supply power to the full authority digital engine control. So what is this flight deck? Flight deck is full authority digital engine control systems. Boeing 777, in Boeing 777, there are total 13 PMGs across the aircraft, critical control systems. So in one aircraft, just I am giving Boeing 777, we have 13 PMG across the aircraft, critical control systems, flight control, engine control, and the electrical systems. So we have 13 PMG. So in one aircraft. Some military aircraft use emergency power unit, is called EPU, for the supply of emergency power. But in some military aircraft, we use something different. It is called the emergency power units, and that supply power for the engine system. Now, backup converters. What is the backup converters and how it is working? I am going to discuss about this system. So, the requirement for ETOPS. So what is ETOPS? It is Extended Range Twin Operation Approval. Extended Range, T for Twin, O for Operations, OPS means Operations, and Approval. So, the requirement for ETOPS have led to the need for an additional method of backup power supply, short of deploying the RAT, that should occur in only the direct emergency systems. We can use this ETOPS. Backup generators are driven by the same engine accessories, gearbox, but are quite independent of the main IDGs. The backup generators are variable frequency and therefore experience significant frequency variation as engine speed varies. So, IDG is what? It is integrated drive generator. So, the variable frequency supply is fed into the backup converter, which using the DC link techniques first converts the AC power to DC by means of rectification. The converter then synthesizes three-phase 115 volt AC 400 Hz power by means of sophisticated solid state power switching technique. The outcome is an alternative means of AC power generation which may power some of the aircraft AC bus bar. So this provides the AC power, and this AC power will be supplied to the bus bar, and I have already explained what is the bus bar. Bus bar is nothing from, but it is a point from where you take out the power and you supply for the different systems. So these are the backup converters. Now, PMG and PMA complement. PMG, permanent magnet generator, and permanent magnet alternator. Alternator means it will give the only AC power, and if we talk about PMG, it can give DC power also. So here we have then a system is shown here about the right engine and the left engine. Here we have the auxiliary power unit. Auxiliary power unit will also have a generator 1. Here we have the right engine, so right main generator 1, this is the main generator. Then we have the right backup variable speed constant frequency generator 1. Then we have the right flight control DC 2. Then we have the right main engine FADEC channels A and B by this 2. If you see here, the left engine will also have the left main generator. From here we have the left backup VSCF generator 1. Then we have the left flight control DC 2, and this will give supply to the FADEC left main engine FADEC channel A and B and 2. So this is a simple configuration for the PMG PMA complement of the power supply in case of emergency. This type of systems are working. Okay, so now these systems we have discussed, it is normally used for all other sources, but for aircraft we need some modern systems, and these modern systems has to be worked, and they are part of the recent system developments. So here we have 3 types of recent development in power supply of the aircraft in aero domain. That is electrical load management system. It is called ELMS. Then we have the variable speed constant frequency cyclo converter. Then we have the 270 volt DC system. So these are some modern systems which are normally used in aircraft. So here first I am going to talk about electrical load management system. How the load is managed, how it is properly distributed, and how there should not be any problem that one side the load is high, another side is low. So there may be some chances of failure. There may be chances of some burning or the short circuit of the electrical system. This has to be avoided, and this can be seen here that we can see that it is a left IDG here, and here we have the right IDG. Here we have the backup generators. Here we have the APU generators. We have the SEC exit power, right generator, random air turbine, just now I have discussed. Here we have the extension power. Here we have the P200. Here we have the P100, power 100. They are given the name left primary power panel and the right primary power panel. High power loads. This goes to the P210, P310, P320 and P110. So this 100, so 110. So like this it is classified, and then it goes to the left power management panel. So here power management panel, it is a computerized system from where power will be taken and it will be distributed. Ground servicing and handling panel. Then standby power management panel, right power management panel, it goes to the electronic unit, and from here it goes to the aircraft systems A629 data bus bar. So this is a simple electrical load management system I have shown for one of the aircraft, and it is working as per the given diagram. Now, electrical load management system ELMS, I have shown the diagram. I am going to explain this diagram in these lines. The system comprises 7 power panels, 3 of which are associated with primary power distribution. They are the P100, left primary power panel, distributes and protects the left primary loads. P200 is a right primary power panel, distributes and protects the right primary loads. P300 is auxiliary power panel, distributes and protects the auxiliary primary loads. The secondary power distribution is undertaken by 4 secondary power panels. So these are the primary 100, 200, 100, 200 and the 300. This is for the left side, 200 for the right side and 300 is for the APU. Further, it can be divided into P110. So means 100, 110. It means it is a part of the primary one. So left power management panel distributes and protect power and the control loads associated with the left panel. P210 is from the right power management panel, distributes and protect power and controls load associated with the right channel. P310 is standby power management panel, distributes and protects power and control loads associated with the standby channels. P320 is the ground servicing handling panel, distributes and protect power associated with ground handling. So here it is very much compulsory to understand how these things are divided. All the power sources we can divide into the three groups. One is the left primary, another is the right primary. At the center we have the APU. And they are always designated as P100, P200 and the P300. Again, the left primary can be divided into 110, P110. It is the left power management panel that distributes the and protects the power for the left side. P210, it is a right power management and which is used for the right primary power panel distribution. And P310 is standby, which is taken out from the auxiliary power unit. Another one is a P320. This is a ground servicing handling panel. This is used for the protection from the ground panel. Because once the aircraft is on the ground, the maintenance work is performed by using the ground source, not from the engine. So that time we should use the P320 ground servicing and handling panel, and this distributes power for the required system. Now I am going to discuss the next very important topic is variable speed, constant frequency generators. What is the meaning of this variable speed and constant frequency system? So there are considerable benefits to be accrued by dispensing with conventional alternating current power generation techniques using IDG to produce large quantity of constant frequency 400 Hz 115 volt AC power. The constant speed element of the IDG is generally fairly unreliable compared to the remainder of the generation system. The techniques are now available through the use of VSCF to produce significant quantities of primary AC power by means of constant frequency power generation accompanied by suitable power conversion. So these are the things here. So simplified variable speed constant frequency system. Here just you can see here we have the variable speed mechanical input power. Here you will have variable speed, but here we have the brushless AC generator. From here it goes to the IDG. Here if you see electronics converter, frequency converter and the filter capacitor assembly. Here is the generator control unit. This is, as you can see, whatever frequency is here, it will give your required frequency. You will get 3-phase 115 volt AC 400 constant frequency power output. So this is called VS, variable speed constant frequency. You will maintain nearly 400. It means 380 to 420 Hertz. This is the range of this frequency you will get. 115 volt AC and the 3-phase. It looks like this. The cyclo converters which is used for variable speed constant frequency generator, it will look like this, as I have shown here. So this is a very important machine in any aircraft power generation, because we need a constant frequency at 400 hertz. And why we need the 400 hertz? Because as much you have the more hertz, more frequency, your smoothness of the current is increased. In house we are using 50 hertz. It is a very low frequency. But if you increase this 400, so the frequency and the fluctuation of your AC will be reduced, and you will get a very smooth flow as per the required, and your system will not burn. Your failure of the systems will be tremendously reduced. To avoid that, we use the 400 hertz frequency normally in most of the aircraft for the any alternating current use. Next, this is my topic for the day, that is a 270 volt DC system. So why we use 270? We have not seen 270 volt in any other areas except the USA aircraft. The modern USA aircraft they use. However, if you see the history, the submarines were using this 270 volt DC very long back, 1930, 1935, even World War. 270 volt DC were used by the US Navy and some other people. So, US military development agencies is the 270 volt DC system, a unique technology. So, mostly till now only US has got this type of technology. The aircraft involved are the US Air Force Advanced Tactical Fighters. Now the Lockheed Martin F-22 Raptor and the former US Navy Advanced Tactical Aircraft A-12 and the US Army Light Helicopter are using this 270 volt DC system. So the use of 270 volt is an extension of the rationale for moving from 28 volt DC to 115 volt AC. So the use of 270 volt DC is an extension of the rationale for moving, because we are using now 115 volt AC. To avoid this 115 volt AC, if we use the DC, the electromagnetic radiation of this AC is very less. So, but this 28 volt AC is not sufficient to handle the big equipments like radar and all. So we used to operate 115 volt AC, but few aircrafts like I have explained you F-22 Raptor and the A-12 and all, they have started using 270 to replace 115 volt AC. So what is the benefit of this? Reduction in the size of the current carrying conductor. The wire which you are transferring the power, the size and the weight of this thing is reduced. So it will minimize the weight. It will minimize the voltage drop, and the power dissipation will be very tremendously reduced. So what is the disadvantage of this? It is costlier than the previous one. Greater reliance on insulation techniques to avoid voltage breakdown. So the cost of these equipments are also high, and the insulation, it is very high insulation is required so that the leakage should not take place on this system. So I have shown here some F-22 electrical systems I have taken from, this is the reference. So here this you can see the firm line is 270 volt DC power. This is the dotted line is 115 volt AC power 3-phase. Here we have the 28 volt DC power. So in this aircraft we use all three types of systems. So now you can see that where we are using 270 volt DC, where we are using the 115 volt AC, and where we are using 28 volt DC power supply. This you can see here that G1 and G2 both are generating the 270 volt AC main aircraft generator, and here also 270 main aircraft generator. This will come to number 1, 270 volt DC bus bar. Number 2, 278 bus bar. From here, if you see, here DC to AC converter. We have to play. If you want from DC to AC, you have to put a DC AC converter. Here also you have to put DC AC converter. Here also you have to put DC and AC converter, and here also you have to put DC and AC converter. So from here, if you see the first case, number one, 115 volt AC bus bar, then 115 volt AC PDC power distribution control here. If you see here again, it is from here it is going number one, 270 volt DC bus bar. If you see here, it goes number one, 28 volt DC bus bar. Okay, 200. So it is converting 270 to 28 volt DC, 270 to slash 280 volt PDC. So here you have both 28 volt DC and 270 volt. Here we have the AC. Same way is here also. If you see DC AC converter, here it will convert number 2, 28 volt DC bus bar, 270 by 280 here, both are here. But if you see in this only, DC is converted to the 115 volt AC PDC, and this is a typical 270, but the main power generation is 270 volt DC only. From this DC you can convert to AC, and also 270 volt DC you can convert to 28 volt DC also. So wherever the equipments are there for different ratings, different types of current, these things you can convert by using different methods. So more electric aircraft, it is called MEA. Nowadays, for at least the last 10 years, a number of studies have been underway in the US, which have examined the all electric aircraft. Means total aircraft, the electric aircraft. As stated earlier, aircraft developed in the UK in the late 1940s, early 1950s, such as the V bombers, utilize electric power to generate extent that present day aircraft. In the 1980s, a number of studies promoted by the NASA, the US Navy and the US Air Force development agencies and undertaken by Lockheed and Boeing addresses the concept in detail. The concept addresses more energy efficient ways of converting and utilizing aircraft power in the broadest sense, and therefore has a far-reaching effect upon overall aircraft performance. So more efficient machine we have to generate. The USA has done a lot of work, UK and other things, to generate efficient aircraft, electric aircraft. Benefits. What are the benefits of the 270 volt DC aircraft? That we have to DC power system. So during the last 16 years, there has been a growing change of third system using 270 volt DC. The 270 volt DC system for aviation was first defined in military STD 704B17, November 1975. Battery system in this voltage area had been utilized in submarine since 1900. From the 1900 onwards, 270 volt batteries were used to operate the submarine engines. The old reason for the 270 volt DC system was increased power density and the capacity. So first thing is power, it increases the power density, means for a small size, more power is available and the capacity of this thing. That is the primary reason. The new interest is due to the stealth. This I have already explained that. This gives the stealth capacity of the aircraft and design changes in modern fighter aircraft. So this has made the modern aircraft very stealth aircraft, and that is why the modern aircraft, especially F-22. F-22 is such aircraft made by the Lockheed Martin for the US Air Force and the US Navy. They have not supplied this aircraft to any country. This is only held by the US military, and no other country they have given permission to take this aircraft. And this is the reason, because 270 volt DC, no other country has got this technology other than the USA. Alternating current systems such as 400 Hertz are not as stealthy as direct current DC. So if you use the 400 Hertz AC, it is not so stealthy. But DC, if you use, it is much stealthy, because in this electromagnetic radiations are very, very minimum compared to the AC power generation system. So although the 270 volt DC military specification introduced in 1975 and last updated in 2004, that is military standard 704F, is still in effect. It does not contain all the requirement needed for the modern 270 volt DC fighter aircraft. Okay, however, this is not very much specific. It is very secret and it is not specified in 100%. The new generation aircraft, especially F-22 Raptor and the JSF Joint Strike Fighter F-35 Lightning, require a system that is more precise, has faster response, and is tailored to specific requirement of the aircraft manufacturer. So these two aircrafts, Raptor F-22 and F-35 Lightning, that is the Joint Strike Fighter, these two aircrafts are more precise, more accurate, has faster response. The response of the equipments, radars are very fast and is tailored to a specific requirement of the aircraft manufacturer. And so this 270 volt is used for this type of aircraft. Simply put, although this is a 270 volt DC system, the requirement define a power supply that far exceeds the old 2004 military standard 704F performance. So 270 volt DC, the requirement defines a power supply that far exceeds the old 2004 this standard. So now whatever we are using, they are far more than this, whatever they have defined in long back. This required the creation of a 270 volt DC system specified to the new aircraft, especially the modern fighter aircraft. The previous generation of the fighter aircraft use a dual hydraulic system to move the flight control surfaces. This presented a large vulnerability should the aircraft suffer damage and fluid loss. Newer aircraft now utilizes multiple electrical driven hydraulic actuators at each control surfaces. This now requires the electrical system to respond to rapid load changes while maintaining a constant voltage. Radar systems require more pulse power while the voltage stays constant. So these are the systems which further required a 270 volt, because the hydraulic system is okay. But nowadays we are using fly-by-wire where we use the electrical system. So if you use the electrical actuators are not able to take that much load as hydraulic system. So we need a high power and high voltage constant power supply like 270 volt DC supply. And also the radar is taking huge amount of power, and once the radar is on, all of a sudden the power drop will be there. But if you use the high voltage, it can be also be a constant system. So the aircraft 270 volt DC power system is ideally suited to meet all the demands. The performance of the onboard power is matched by the performance of the external power supply built by this FCX system. This allows full maintenance, including flight control response test, to be performed inside the hangar. So a company, it is named FCX system, they have produced this type of, and you can test these things in the hangar also, the system of 270 volt DC. This you can see one figure here. This is the FCX system of the performance of FCX system. 270 volt DC power is flight line and production line proven. So we are 270 volt DC from the ground up. Installation sites include main production and the test site such as Lockheed Martin F-35 assembly in Fort Worth, TX, Navy F-35, T&E, NAS, Patox River, and at Edward AFBCA FCX system precision 270 volt equipment is the preferred and best power of the choice for all 270 volt DC supplies. So this is the company FCX and they are the equipments. They are used for testing of all the controls and other things of the 270 volt DC power supply. Here I have shown 270 volt DC power converter. Here it is converting from one to another. Here also, if you see here, the 270 volt DC bus bar, and here constant voltage load, and here constant current load. So here is this is the current, and this is the voltage. So these are the systems which are used for this. These are the references I have taken from this Moir I and the series, aircraft systems, mechanical, electrical and avionics system. Then the next reference is a book, Design and Development of Aircraft Systems and Introduction. And this last 2-3 slides I have taken from HTPF. This is the aviation industry. This I have reference number 3. Any questions you are welcome to ask. Actually, I feel very nice that this 270 volt DC supply, you have got some knowledge on that, and it is very good to replace the 115 volt 400 hertz alternating current system, because this is not very much suitable for stealthy pattern of the aircraft, because this 400 hertz emit lot of energy, electromagnetic waves. These waves can be captured by another aircraft or some missiles, because nowadays the missiles are capturing the electromagnetic wave of the aircraft and they are following as per that. So either infrared systems or this EM waves and all. So if you are able to reduce this signature of electromagnetic wave, the stealthy of the aircraft will be increased. That is why F-22 and F-35, they are deemed to be one of the best stealthy aircraft of the world. Okay, so thank you very much for the joining. And if you have any questions, you are welcome to mail me in this email. Thank you for joining and thank you for listening, and be tuned for my next lecture. I am going to discuss some new topics in due course of time. Thank you very much for joining this class.
Like, share and subscribe. Hit the bell icon for more updates.